Okay, so in this video, what we're going to be doing is we're going to be talking about UPCs. UPCs stand for Universal Product Codes, and they're associated with the barcodes that you see on literally anything and everything you buy in a store. Anytime you go to Walmart or Target, you're going to see one of these codes on the things they sell. And fun fact, the first thing to actually have a barcode was Wrigley's chewing gum. But every time you see one of these barcodes, you're going to see these numbers at the bottom. And the first few represent the manufacturer number, the next are the product number, and the last one is a check digit number. The check digit number is the most complicated one. Even though it's a single digit, it's the most complicated. So the check digit in a UPC number, which is the last one, the 12th digit, is determined by the following manner. So we multiply the first digit by 3, add the second digit, multiply the third digit by 3, add the fourth, and so on and so forth in an alternating pattern for the digits 5 through 12. So it says a check digit is chosen so that the calculation described previously totals a number whose final digit is 0. So I'm going to underline that. That's important. Final digit is 0. Final digit is 0. And it says in the UPC number A1, A2, all the way through A11, and then D. D is the check digit number. That's that last number. D, the check digit is D, for which the sum 3 times the first plus the second plus 3 times the third all the way plus D ends with 0. And so this is another form of weighted averages. The odd numbers have a weight of 3. The even numbers have a weight of 1. And so what we're going to do is that it says show that this number, this UPC, is a valid UPC number. And so we're going to use this formula that we just learned to do that. So we know that all odd numbers are multiplied by 3 and all even numbers are multiplied by 1. So what I'm going to do is I'm actually going to cluster all of the odds together since they're multiplied by 3 and all of the evens together since they're multiplied by 1. So I'm going to have 3 times odd numbers plus, well, we know evens are multiple of 1, so 1 times even numbers. Okay, here, let me flip my page real quick. So what this has to do is that all of this value has to equal a number that ends in 0, okay, for it to be a valid check number. This one right here. So what I'm going to do is I'm just going to identify all the odd numbers, all the odd digit numbers. So this is an odd because it's the first one. This 8 is the third one. 0 is the fifth one, and so on and so forth. So I'm just going to underline all of these odd numbers. Here, let me erase that. This 5 is not an odd number. So I'm going to have 3 times 0 plus 8 plus 0 plus 4 plus 8 plus 6. And then close parentheses, and then I got 1 times all the even numbers. I got 5, 2, 8, 2, 5. So 5 plus 8 plus 2, plus 0 plus 8 plus 2 plus 5. So if I add all this up, I should get 3 times 8, 12, 26. And then plus 1 times 22 on the inside of this one. And if I multiply this out, 3 times 26 is 78. 1 times 22, that's just 22. 78 plus 22 equals 100. And since this digit, or this number, ends in a 0 as the last digit, then we can say this ends in a 0. So it is a valid UPC. Check. Okay, so that one works. What about this one? It says, show that this number is a valid number. So again, I'm going to do the same process. I'm going to have 3 times all my odds. So I got 0, 2, 0, 4, 8, and 6. So I'm going to have 0 plus 2 plus 0 plus 4 plus 8 plus 6. And then I got 1 times the rest. So I got 5 plus 2 plus 0 plus 8 plus 2 plus 5. So if I multiply this out, I should get 3 times 20 plus 1 times 22, which equals 60 plus 22, which equals 82. So since this one does not end in a 0, we can say this sum does not, underline that, does not end with a 0. So it is not a valid UPC. Okay. And now it asks us, if someone made a single digit error when entering this valid number, can you tell which digit is incorrect? Why or why not? So we have all of these numbers up here, all 12 of them. If someone were to make a mistake, do you think by going up or down one value, do you think that we would be able to tell? Well, there's so many numbers here, we wouldn't really be able to tell because there's just too many variables involved. So what we're going to say is no, we would not be able to tell. Any single digit could be adjusted. Okay, so any of them could change and cause a whole thing to be thrown off. Part C says change one digit in this invalid number so the resulting number is valid. So there's a bunch of ways you can do this. So some examples, you could change the second, so change second 0 to 6. You could change first 2, the first 2 in the number to 0, or you could change the third 0 in the chain of numbers to an 8. So, and these aren't the only ones. If you can think of another one, if you plug it in and check, and it equals a number that ends in 0, then it's good. And then the last one, determine the check digit, or D, for the UPC number right here. So remember, all of this has to add up to 0, right? So again, I'm going to take all the odd numbers and multiply them by 3. So I got 3, 1, 7, 0, 2, and 3. So 3 plus 1 plus 7 plus 0 plus 2 plus 3. Let me double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we're good. And then all the even numbers multiply by 1. So I've got 8 plus 3 plus 0 plus 9 plus 1 plus D. Remember, D is an even number. So if I simplify this, I should get 3 times. On the inside here, I'm going to get 16 plus 1 times. I'm just going to pull this D out. I'm just going to pull the D, put it right here. On the inside, I'm just adding up all of these values right here. So these all add up to 21. And if I simplify this further, 3 times 16 and 1 times 21, add those together and I should get 69. Bring the D down. So 69 plus D. All of this has to equal an even number. So the next equal number above 69, or excuse me, the next number that ends in a 0 above 69 is 70. 70 ends in a 0, right? So if I equal this to 70, try and solve for D, move 69 over, I get D is equal to 1. So D has to equal 1. D has to equal